Hi, today we're going to be solving exponential equations, which looks something like this. Your variable, whatever it is, x, y, v in this case, etc., is up in the exponent. This should be a review of something you did earlier this school year. The key thing you want to do here is, in order to get rid of all this exponential craziness, is we need to make any bases we have the same base by doing some converting. Once you've done that, you'll use your exponent rules to simplify the expression as much as you can, and then I'll show you the rest. I have kind of a shortcut version of the steps we're going to follow up here, and I'll refer to those as we go. So this first one, I have a base 9 and a base 27. Can I write both of those with the same base instead of bases 9 and bases 27? And just to jog your memory here, I'm going to help you with these first two. 9 is the same as 3 squared. 27 is the same as 3 to the third. Notice that these now have both a base of 3 if I rewrite them in this other format. So what I'm going to do is I'm going to take that 9 and replace it with a 3 squared. I'm going to keep the existing exponent it already had. And then 27 just becomes 3 to the third. So what I've done is I've made my bases match. The next thing I'm going to do is use my exponent rules to simplify things. We know that if I have an exponent on the inside and an exponent on the outside, I need to just multiply those exponents together. So 3 squared with a 2v minus 2 on the outside is the same as 3 to the distribute the 2 exponent. 2 times 2v is 4v. 2 times negative 2 is negative 4. Other side is as simple as we can get, so I'm not going to change anything there. Now the next thing I'm going to do is I'm going to cancel any matching bases I have. There's a mathematical property that we can use. If the bases are the same on the both sides, I can cancel those bases and then solve the equation that I'm left with. So my equation is now much simpler to deal with. It's just 4v minus 4 equals 3. This looks like something you've been solving for a long time in your math career. So let's finish it out. I want to get v by itself, so I'm going to add 4 to both sides. And then I'm going to get v completely by itself by dividing both sides by 4. I'm just going to leave my answer as a fraction 7 over 4. You could write it as a decimal also, but that's another step, so I might as well just leave it as a fraction. So we made our bases match. We used our exponent rules to simplify any exponent stuff we had going on. We canceled out our bases, and then we solved the equation we were left with. Next one. So I have, let's ignore the fact this is a fraction for just a second. I have 216 and I have 36. I can rewrite both of those using a base of 6. 216 is 6 to the third. So if I want to write 1 over 216, I need a negative exponent. So reciprocals come from negative exponents. If 216 is 6 to the third, 1 over 216 is just the negative version of that, 6 to the negative third. 36 is 6 squared. So then from here, we can do the same step we did last time. I'm going to turn this 1 over 216 into 6 to the negative 3. I'm going to leave that existing exponent the same. 36 is the same as 6 squared. I'm going to simplify with my exponent rules. I need to distribute this negative 3. Negative 3 times 3p is negative 9p. Negative 3 times 2 is negative 6. Other side's as simple as it can get. Cancel our matching 6 bases and solve the equation we're left with. This is just algebra 1 type stuff, so it's pretty easy. Add 6 to both sides, and then divide by negative 9 to get p by itself. Once again, we get a fraction answer, and that's okay. Negative 8 over 9. I'd like to try 2 more with you that are similar. And I'm going to leave my little purple notes up there because we're going to come back to problems that have these same bases, so might as well leave them there to help us out. And if you're hearing a weird rumbling noise, I have a creaky spot in my floor here, so there it is. It's really annoying. Okay. And then the other one. So 2 more and then we'll call it a day for this video. It just so happens that we have the same bases as last time, so I can use the same replacements I did last time. 27 is the same as 3 to the third. 2m plus 2 stays the same on the outside. 9 is the same as 3 squared. Leave that m minus 1. And then 9 is still 3 squared over here. Okay, so we've got a little bit more going on this time, but nothing we can't handle. We know from the last couple problems we need to distribute these exponents here. 3 times 2m is 6m. 3 times 2 is 6. Same idea down here. 2 times m is 2m. 2 times negative 1 is minus 2. This side's as simple as it can get. What else can we do here? Well, we know that our quotient rule says if I have division going on, I subtract top exponent minus bottom exponent. So this becomes the same as 3 to the top exponent stays the same, and then I'm going to subtract the whole bottom exponent. So what I did here is I did minus parentheses around the whole bottom exponent. We'll distribute that negative later. If you want to combine some steps and you do this on your own, go for it. All right, so now from here, I can cancel my matching 3 bases, and I'm going to simplify what I have here by distributing the negative. So 6m plus 6, this becomes a minus 2m, this becomes a plus 2, and the other side is just 2. From here, I'm going to solve this equation I have written in red, but I'm going to do that up here because I'm kind of running out of room. So it's the same exact thing. 6m plus 6 minus 2m plus 2 equals 2. I just copied that down. All right, let's solve that out. I can combine some like terms here. 6m minus 2m is 4m. Now my dog is being dramatic on the other side of the door. 6 plus 2 is 8 equals 2. And just solve that out. So subtract 8 and divide by 4. Leaving this as a fraction, negative 6 over 4 can be reduced. I can divide both of those by 2. I get negative 3 over 2. You can also use a calculator to help you reduce that fraction. All right, one last one. So we have 216 and we have 36, so it's the same stuff we did before. Since we don't have a 1 over 216, we don't need this one, so I'm going to scratch it out. I'm going to turn that 36 into a 6 squared. Keep the 2x minus 2 the same. 216 is 6 to the third. Keep that x on the outside the same. 36 is 6 squared. Keep that x on the outside the same. Lots distributing. So multiplying by 2, I get 4x minus 4 here. Multiplying by 2, I just get 3x. Multiplying by 2, I get 2x. Thinking back to our exponent rules, when I am multiplying 2 things with the same base, I'm going to add the exponents. So this becomes 6 to the 4x minus 4 plus this exponent 3x. Other side stays the same. Now that I have the same base on both sides, cancel, cancel, and I solve the equation I'm left with. To solve this out, I can combine my like terms. 4x plus 3x is 7x. I need to get my x's on the same side of the equal sign, so I'm going to subtract 7x from both sides. And then last but not least, I need to divide by the number in front of x. And writing my answer as a fraction, negative 4 over negative 5 is the same as positive 4 over 5. So you would normally see negative 4 divided by negative 5, you would just see a positive fraction instead. That is it for solving exponential equations. Have a wonderful day.